Hi, welcome to this presentation on multitask training on X-ray images. The objective of this project is to explore multitask learning on X-ray chest images for the detection of pneumonia and tuberculosis. The statistics for training tasks individually in a multi-class setting and in a multitask setting are compared. And we'd like to see if the similarities between the two diseases can help improve training statistics in a multitask setting. The data sets are downloaded from Kaggle. The pneumonia data set is about 10 times bigger than the tuberculosis data set. And the images are resized to 256 by 256 grayscale. All the training uses 80-20 split and 30 epochs. And data are randomly shuffled before each experiment. Here we see some photos from the data sets. The architecture diagrams are shown here for the models. Individually, there's a convolutional layer which gets flattened out into a dense 64, and that turns into a dense 2, which is for detected and not detected. In a multi-class setting, everything is the same as the individual, except for the final layer. It's a dense 3 for nothing detected, pneumonia detected, and tuberculosis detected. In the multi-class architecture, we split off after flattening the first convolutional layer into 2 branches, and those branches represent the same architecture as the individual model with 64 dense and then dense 2. And then a second model is trained for multitask, where we reduced the dense 64 into dense 32 to reduce the degrees of freedom, and this is to address any concerns over the multitask model having more degrees of freedom. Even though the extra degrees of freedoms are ignored when the tasks are examined individually. Methodology for multitask. During training, all the inputs from the other data sets are labeled as false. So when calculating precision recall for one of the tasks, only the predictions associated with the input is looked at. So in other words, we ignore TB predictions in the statistics if the input image is from the pneumonia data set and vice versa. This adds a lot of labels that are marked as false during training. So here are the results for individually trained tasks. Pneumonia has almost 96 and 97 for precision recall, while TB has a lower 81 and 89. When we put them in a multi-class setting, pneumonia stayed about the same, but TB went up a little bit for both precision and recall. So in a multitask setting, all of the statistics went up, but we will focus on the reduced degree of freedom multitask setting. So for that one, for TB, the precision and recall went up a lot. Even though the degrees of freedom were reduced, they were only running on a 32 dense layer. And for pneumonia, it dropped very slightly. Here is a summary of the results. We will focus on the TB side because there's 10 times less data. And so we can see for single precision it was 81. In the multi-class precision, it went up almost 4%. And then in the multitask reduced degree of freedom, it went up almost 8% from the single model. So in conclusion, when examining the reduced degrees of freedom from the TB dataset, from the TB model, we see that it is able to perform much better in the multitask setting. This may be due to the increased number of training samples that are marked as false from the pneumonia dataset used during training but ignored for prediction. All right, thank you for watching.